All right. Yes, this works. Fantastic. Could I get a timer started? Yes. 20 minutes. Fantastic. All right, cool. Yeah, thank you everyone for coming. I'm going to talk about the distributed operating system for Web3, or the move from virtual machine to intent machines, and why intents matter, and how intents fundamentally work, and how we can use intents to connect all these things together. So, brief recap, because I think it's always good to remember where we came from. So, what does the evolution, like, how did we get to where we are today? So, what were the fundamental steps that we actually took? And really, and people may disagree with this because we've sort of like called this generation 3, generation 4, and so on over the years. But very fundamentally, we've roughly had like 2 previous evolutions. We had sort of the transaction-centric systems that really started with Bitcoin and Bitcoin-like things. You can think Litecoin, Monero, Zcash. I mean, these were all fundamentally transaction-centric systems, which made a lot of sense if you try to solve for the use case of like, I'm going to a store to buy some milk and here's some Bitcoin, right? Like that's a fully balanced transactions and you can immediately execute this. And then over the years, we tried to build cooler things like NFTs and so on onto these transaction-centric systems, and it didn't work. Like we got the colored coin things and so on. And like, I don't know, like, or the global Bitcoin stock exchange and all these things. Like if you've been around long enough, you'll remember some of these early attempts. And out of this really came the VM-centric world. Starting with Ethereum, which were fundamentally about virtual machines and having this ability, full programmability over the transactions. So all of a sudden we could build NFTs, ERC20s, multi-sigs quite easily. And really, like this is currently still the predominant model that we have right now. Like if you look at, I don't know, Solana, Nia, and so on, Polkadot, these are very fundamentally virtual machine-centric systems. I mean, yes, some have different consensus mechanisms, some are differently sharded, some have higher throughput numbers, but they're fundamentally the same model of like, this is a virtual machine, and we will send a transaction to it to update some global state, and then we move on, right? And sort of the next generation, so the next fundamental step function is the intent-centric design, which, sort of as Ilya was mentioning earlier, is also fundamentally required for things like AI agents. And it's this ability to express partial state transitions, right? When you think of it, most users, when they interact with the world, don't have a transaction. They have a desire. They have an intent of like, I would like to get something. But they don't exactly know how to sort of like service this. Again, in a supermarket, this is very easy because like you see the thing that you want to buy in the store. But think of sort of the use case of I would like to sell some ETH for Bitcoin. I don't have the inverse. Like I know that I have my partial state transition, but there now need to be a number of other parties that like someone else needs to take the inverse of this. And so the other party also has an intent. And the fundamental difference is that intents aren't directly settable on chain because they're partial. They cannot directly update some global state, and you ideally want to be able to issue them like every half a second kind of thing. Like if I'm trying to just trade some ETH for Bitcoin, I'd like to like sign and send a new intent every 200 milliseconds, and I don't need to get global consensus on this. Like I can choose who to send my intents to. Maybe I just send my intent to you. Maybe I send it to this entire group. I can really make my preferences very clear on how far I'm willing to broadcast my intent, whether I'd like to do global broadcast or just local broadcast, right? And this is sort of like, these are the step functions. There's a bunch of other things that I'm not going to touch too much on today, with regards to privacy guarantees and sort of like why intents are much better abstraction, for example, for ZK proofs, because fundamentally ZK proofs move data to the edges of the network, to edge devices, and intents allow you to reason over sort of your local state on your edge device, right? Because in this world, in the VM-centric world, in the TX-centric world, we all had this large global state blob in the middle, right? Like when you think of Ethereum, it's a large global state blob that like everyone agrees on and everyone syncs. As soon as we move into a ZK-based world, we don't have this large global state. We have a hash. And now we have to have lots of state in lots of different places, and intents allow you to reason over sort of these like far out on edge devices, on edge device living state. So yeah, TLDR, in Bitcoin you authorize transactions, in Ethereum you authorize execution traces, and in Anoma and with intents you authorize specific end states. And sort of like, what is the fundamental difference between the last two? When you sign a transaction currently, you really sign over a number of opcodes. You don't sign over, this is the specific end state that I want, you sign over, these are the compute steps that you're allowed to run in order to compute the underlying outcome. This makes it very difficult for people and user interfaces to show specifically what will happen, because it depends on how you interleave these execution traces and so on. And it's very, like, my parents will never understand this model, fundamentally, because they, like, it makes no sense to them that they have to, like, inspect the opcodes that they're signing over in order to understand what's going to happen. With intents, you much rather authorize specific end states. You sign over the specific thing that you're willing to hold in the future. Like, you can think of this as like a state change plus a condition where, like, I currently hold some ETH and I'm willing to hold some Bitcoin and I'm willing to hold X amount of Bitcoin if and only if the weather in Paris is nice. You can make them arbitrarily complex, and this is also one of the big differences. Like, Anoma is the first generalized intent. Yes, this worked. It's the first generalized intent machine. Because a lot of people say, like, oh, intents, well, these are just limit orders, and this is simply not true. Like, with generalized intents, you can encode everything from sort of simple multisigs, because fundamentally knows the safe is an intent-based system, because, like, partial signature, like individual signatures to a multisig are just intents, because you can't directly settle them, they're partial, to incredibly sophisticated things like my AI, like my local AI agent, please figure out for me how to get me a rare rainflower from the Amazon. I send this as an intent, for example, to an agent running in TEE, and then the TEE sends out a bunch of other intents that are to figure out whether this is capable, whether this is possible, and then in the end, I just get returned what I wanted. Or, and this is very important to understand, not all intents are satisfiable. Like, if you want to buy Bitcoin at $1, I mean, you can issue this, and if you're lucky, at some point someone fills this. But just because you have an intent does not mean that you guaranteed settlement. Yeah, so, and Anoma here is two things. Anoma is a protocol that describes a distributed operating system for intent-centric applications. And then Anoma as a network is how all these different nodes are linked together. And we'll cover this in a second on what it means for sort of why this is a distributed operating system and how many different nodes in a network can, like, run the Anoma protocol. So, for example, you can run Anoma on NEAR or on Ethereum, and that allows users to then treat this as a homogeneous environment, as in they have a homogeneous operating system to interact with, that abstracts away the complexity of the sort of heterogeneous deployment across all these many nodes. Yes, and then just very briefly, what is a VM? A VM is an instruction set. It has a program counter, has different layers of memory, and so on. Examples are like the Ethereum virtual machine. And what is an IAM? An IAM is an intent machine, takes a batch of intents, computes valid possible state transitions, and selects one according to some criterion. And this criterion could be chosen by a solver. This criterion could be somewhat constrained on chain, as in the application, you must pick the best possible solution under some closed function of, like, what are the best possible states. But yeah, and so we really currently don't have any intent machines. The first one that I'm aware of is the Anoma resource machine, or the ARM. Check it out. There's a very cool spec in implementation nowadays. Yeah, so this gives us, and maybe, yeah, I mean, on here, it's like, what does this IAM do, actually? This IAM abstracts diverse sets of hardware behind a universal interface. And this could be abstraction between, for example, different chains, different specific consensus systems. This could be an abstraction behind different kinds of compute providers, right? Like, some may be very good at solving with GPUs, some are very good at solving with CPUs. Like, the intent machine abstracts specific underlying hardware into a uniform interface. And it provides an abstraction or an environment in which applications can run. And maybe one of the coolest things, this works in single execution context. So, like, if you deploy this just to Ethereum, this also just works on Ethereum. Or if you deploy this to global Anoma, this just works in global Anoma. But as a developer, it also allows you to treat many different connected deployments of the intent machine as a uniform operating system. Like, this is where this distributed operating system comes from. You don't have to sort of, like, figure out a new RPC endpoint to talk to in order to talk to Ethereum or to NEAR or to Solana. You just talk to the P2P gossip stack, and in code you define, well, I would like to, like, settle this trade on Ethereum, or, like, I'd like to send some NEAR from Ethereum to from NEAR to Ethereum, and so on, right? So, like, instead of having to worry about all these different chains, you can just worry about one abstraction and build against the single abstraction. And I think most people don't appreciate this enough, but there will be hundreds of thousands of blockchains. I think like what we're seeing right now is like the tip of the iceberg. Very practically speaking, like my phone is going to be a 1/1 blockchain. Every phone in this room is going to be a 1/1 blockchain. Like my computer and my phone will be two different chains essentially, and like we can use this kind of abstraction to allow to, for example, figure out how to synchronize data between my phone and my computer at home. This is sort of what this uniform abstraction allows you to do. There we go. All right, so fundamentally, it's a new paradigm for infrastructure. So rather than being very VM-centric, we can now focus on applications being very intent-centric. dApps can very much go beyond the limitations of what's possible in a transaction-centric VM model. This also comes from the fact that the intent machine is very declarative in nature. The way you program it, you just define sort of possible states. You don't define specific compute. Like when you think of a Solidity program is really as like, make this thing red and then make this other thing blue and then increment the counter. And here you just define, in the declarative programming paradigm, you just define, like these are the possible states and this is how you can get to them. Makes verification way cheaper. You can interleave these things very arbitrarily. It's quite nice. And fundamentally for users it means that they don't have to think of single blockchains. They have to like think of like, they want an application and maybe today they want to run it in their local instance in Zurich and maybe tomorrow they want to run it in their local instance in Lisbon, which is actually something that happened to me, right? Like I flew from Zurich to Lisbon. It's like I changed some specific security zone. Or this could be like, well, tomorrow and then the next day I'm flying to Argentina and I'd like to move all my assets into the sort of global trust zone of Ethereum. This is just like, for users, it's kind of like the reason why phones are nice. Like your phone works in China as well as it works in the US without much problems. This is sort of the world we're moving to with regards to blockchains, because currently we live in this world where for like every new country you have to buy a new phone. And so as a result, all of us run around with like 15 different phones and we all look like crazy maniacs. Yeah, this really gives you just apps that work like magic. You simply state what you want and sort of the operating system figures out how to give it to you. And maybe the answer is it cannot give it to you. And that's fine. That's like an acceptable outcome. But fundamentally, you can say, I would like X, and then if X is possible under some conditions, then X happens. Yes, and this is also important. Applications don't live on a specific chain. Like, this is a very big fundamental mental shift that most people have to make. Apps live, like, parts of apps can live in different sort of storage environments, in different security environments. So for example, some assets could live on Ethereum, some like AI logic could live on NEAR. This is like, because the application environment is really like this global computer, this globally distributed operating system, so you're not constrained that all your state must live in exactly the same place. Declare your intent and let Anoma handle the rest. This is just, the important thing to remember here is like, there's no Anoma chain that you must send your intent to. If you want to use Anoma just on Ethereum because you just want to stay on Ethereum, you can. If you just want to use it on NEAR, you can. Like there's no single global routing thing that like you must send your intent to. You can also send your intent to like your local instance run by your local government. Like this is really fundamentally up to you where you want to run these things. So this is sort of like you put an app in and like you put something in and then sort of it just happens and you don't really have to care how this specifically gets executed. It just follows the constraints that you gave in code. And actually, I mean, this is like kind of like under the hood here, there could be an AI agent living in some TEE under some specific security model and you sort of just go, throw your intent in and see what comes out, and hopefully the AI agent does the right thing. But this is really, I think this is going to be the biggest fundamental unlock in terms of UX that we can have. So a new era of decentralized applications where you fundamentally define the outcomes that you want, and the system then figures out whether it's possible to get them for you, and if so, gets it for you. Fundamentally, Anoma is a universal intent machine for Web3. Oh, wait. Oh, I jumped one too many. Yes, exactly this one. And this is really important to me, like that everyone understands this. Because historically, we've very much lived in this world where like users kind of religiously picked a specific chain to be on. And like this specific thing that you want to be on changes a lot, and it also changes for people. Like to my parents, it is not a selling point that it's globally decentralized. They don't care, and they actually hate it. They want something that their local government controls because they trust their local government. I mean, as I was saying on the panel, if you don't trust your local government, like, technology is not the way to fix this. Like, if you don't trust your local government, move or get involved. So, like, you fix your local government system independent of technology, right? But so as a result, there can be sort of hundreds of thousands of these systems, where there's like a global Anoma L1, a global Solana L1, NEAR, Ethereum, Arbitrum, you name it. Maybe a bunch of government chains, and this is all fine. Like, but as a user, as an application developer, you can treat this as one uniform thing. You don't have to sort of reason about all these, make sure that you understand exactly the peculiarities of whether like Solana or NEAR or how Ethereum works. And I mean, this is like, some people in this room may be old enough to remember, like, but we had this prior to Windows, really, or Linux. Like, you had to write programs for specific CPUs, and it sucked because, like, it would only work on that specific CPU and maybe not even on the same family of CPUs. So, like, you had to keep rewriting your programs, and then with the operating systems, actually, traditional computing came along. All of a sudden, it didn't matter. Like, I could take my program from my local PC to, like, my university computer and so on. And this is what we're getting now with the intent machine for Web3. So, just very briefly, yes, great. Just very briefly, the road to mainnet. So Anoma is coming to mainnet. I mean, this is Anoma is ambitious. Anoma does a lot of things. Like, Anoma innovates around heterogeneous trust. It innovates around how you can reason about privacy guarantees, how you can, for example, you can have very cool flexible privacy guarantees where you say things like, I would like to trade some ETH for Bitcoin, and then you only reveal like that intention, and then maybe only 5 in this room and some size, and then only 5 people in this room respond, and then like only 2 of them can trade the sort of appropriate sizing for the trade you want to execute. So you can like you can have very like fine-grained disclosure of data, and fundamentally you can also decide like, in an intent, you can reveal no data. That makes an intent very difficult to settle. Or you can fundamentally decide what kind of data you are willing to reveal, because all of this is just committed to in a ZK proof. Yes, so the Anoma mainnet really is a version of Anoma which allows developers to build and deploy real applications that can interact with existing tokens such as ETH, BTC, NEAR, USDC, Sol, whatever. I mean, I am not fundamentally token maxi. I think you do you. If you want to like trade in some shitcoin, cool. I just want to build cool infrastructure to make this as smooth as possible. I'm not judgmental in that way. And I don't know if some of you sort of were around a while ago with regard to Plasma. This really looks like an original Plasma construction. So we're calling this the minimum viable resource Plasma because Anoma, it's like the Anoma resource machine is neither it's neither an account model nor a UTXO model, it's a resource model. If you're interested in more, come find me later. So it comes with a framework to write native intent-centric applications and a network allowing those applications to instantly leverage existing services and liquidity. And a clear interface for service providers to easily support new classes of applications. So service providers is something that we really historically call solvers, but they may provide like some data storage, they may provide some consensus services, they may provide the classical idea that everyone has in mind when they think of solver, as in like, I would like to trade ETH for Bitcoin, please make this happen in practice. They may also support, for example, ZK proof generation. If you want to outsource a bunch of heavy compute, this is also the solver abstraction. This is really the abstraction of like, I would like to get something and I'm willing to like encode this, what I want to get, and this is then someone else can sort of come back and like, here, you've got it. So this is a little bit sort of the overall view, where you have users and you have gossip nodes, P2P nodes, that are all connected. And you can really see that this is not a globally connected network, right? Like, different nodes can make different choices of who they're willing to talk to. There should just be some path between different nodes, in different parts of the network, but it's not like everyone has to talk to everyone else all the time. Like, if I don't care about the ETH BTC intents, I can just block everyone that sends them to me. And if you DOS me, I just block you fully by IP address. And so users and developers send from their local Anoma node to some other gossip node or directly to a solver. They can configure this as they'd like. Then solvers sort of like assemble these things. And again, we didn't speak about this today, but in Anoma you can do composable solving. So if I have A for B and you have B for C, a solver can do A for C. This is fundamentally important. If you do not have composable solving, we will get a single mega solver to rule us all. This is a bad idea. And then, essentially, depending on what your intent says, you get settled somewhere. And afterwards, you just have to check that settlement correctly happened. Yeah, so the mainnet phases are, devnets have started. So developers are starting to build applications. You can build a bunch of new cool applications that aren't possible at the moment, that are actually fully decentralized. It's very fun, so please check it out. The code is open at github.com/anoma/anoma. Then we're probably hitting testnets sometimes early this year. So you can have public testnets, and then mainnet probably sometime later this year. And here you can get everything. And this is also like not on the idea of like eventual decentralization. This is on the idea like this like actually is not controlled by anyone specifically, but you rather can just use it. Yeah, please join the community. Find us on Twitter. Find us on Discord. It's cool there.
Hello.
Also importantly, if you'd like to learn more, there's research papers on everything. Or you can find me or anyone from the team to like make sense of everything I spoke about.